Alright, in the last video that I shared with you, I showed you the peeling of the orange and how we got our surface area of a sphere. I also shared with you, not my own video, but another video explaining the volume of a sphere and where that comes from. So I'm going to now show you just a couple examples of how we would use that. Okay, so if I'm looking to find the surface area and volume of this sphere, So surface area, as we said, is 4 pi r squared. And so I'm going to put in, instead of r, I'm going to put in my radius, which in this case is 5. So that's 5 squared. I'm going to do that 5 squared first, because I'm going to do my exponents before the multiplication. And that gives me 25. And now I've got 4 pi times 25. And if we were to write that better, we'd move the 25 to the front, and then it's 4 times 25, which is 100 pi. Now that's actually my favorite way to write the answer, because now pi is an exact value, and I can write it as such. You're probably going to be asked to, from time to time, round. What I would do now that you're working on grade 10 level stuff, hit the pi button on your calculator. Don't use that 3.14 anymore. So use the pi button on your calculator, gives you a more precise value. And as we start working with larger values, those extra decimal places will change our answer. So if I was to multiply 100 by, and I hit the pi button on my calculator, it's going to give me 314.1593, and I'm just going to round there. So we'll say approximately 314.1593, and our units there is centimeters squared. Okay. Now if you're using just the 3.14, obviously 100 times 3.14 is 314. So in this case, it does make a bit of a difference if we're rounding to the nearest tenth or hundredth. Okay, so those extra decimal places will change the answer. For the volume, so our formula for volume of a sphere is 4 pi r cubed over 3. And again, I'm going to replace my r with that given radius. So I'm going to substitute in my 5 and divide by 3 here. So this one would be 4 pi times 125 divided by 3. And again, if I move that 125 and multiply it by the 4, that would give me 500 pi over 3. And that would be my preferred answer because everything is all exact. But if I was to use the pi button in the calculator and then divide by 3 so that it's nice and exact, I get 523.5988, and then I'm going to stop there, and that would be centimeters cubed. So approximately that's what we get. Okay, so that's surface area and volume of spheres. Now, one thing that we should be able to figure out now that we know spheres is we should be able to look at a hemisphere. So a hemisphere is really just half of a sphere. Okay, so when we talk about the northern hemisphere of the world, it's talking about the north half of the world, right? Southern hemisphere is the south half, okay, split at the equator. So let's think of this as our planet Earth because that makes it much funnier. If we were to take a knife and slice along the equator of the world and we split the Earth into 2 separate hemispheres, this is what it would look like. Now there'd be dire consequences, so let's not actually do it. That's probably a bad life choice. But in terms of splitting our hemispheres here, if I was to look at the surface area of a hemisphere, so let's just look at that bottom hemisphere. If I was to think about the surface area, and this is my orange, if I had just cut my orange instead of peeling it, well, now I have half of the peel left, right? So it's really just half of the outside of a sphere. But if I had cut my orange with a knife and I cut it in half, yes, I have half of the peel still on the outside, but I also now have to add in the wonderful, delicious part of the orange that I actually want to eat. And now that the orange has been cut in half, I can touch that inside portion. So if we've cut that sphere perfectly in half, I also now have an additional circle that I need to add in. So I need to add in that extra circle. Now it has the same radius as the hemisphere. So if the outside of the sphere is 4 pi r squared, and I'm going to cut that in half, so now I've got 2 pi r squared, If the radius is the same, well, this circle is just going to be another pi r squared. And since I need to add those two things together, 2 pi r squared plus, and I didn't write it, but we could write it as 1 pi r squared, that gives us 3 pi r squared for the surface area of a hemisphere. Now, I don't necessarily like to work with this formula because quite often when I'm looking at calculating surface area with a hemisphere, often that hemisphere is attached to something. So many times I actually won't even end up using this, and I'm probably just working with half of the outside. But if you do have a hemisphere all by itself, that would be the calculation. Now, volume is much simpler. The volume of a sphere is 4 pi r cubed divided by 3. And if I cut that in half, well, I'm just going to divide the sphere into 2 equal volumes, and that gives me 2 pi r cubed over 3. Okay, so volume of a hemisphere, a little bit simpler than the surface area. The surface area, we have to add something extra in. Volume is simply cut in half. Okay, so now I could do fun questions like finding the surface area and volume of this wonderful ice cream cone. And yes, this is cotton candy ice cream because that is clearly the best one and the one you should always get if available. So this cotton candy ice cream cone, if I'm going to find the surface area and volume, so if I think about the surface area here, I have a hemisphere. But with that hemisphere, since the cone or the ice cream is sitting inside the cone, I only have the outside part. I don't have that extra circle. Okay, so I'm just working with the outside part of the hemisphere, so that is a 2 pi r squared. I don't add in that extra circle, it is covered. And we can probably safely assume that unless you've gone to the worst ice cream shop in the world, they did give you the full sphere, you just only have half of it sticking out of your cone. All right, for the cone itself, well, it's a cone shape, so remember the cone, we had pi r squared for the circle, for the bottom of the cone, plus pi r s, where s represents the slant height. But in this case, I don't have the bottom circle of the cone because that's where my ice cream is. So I'm going to eliminate this part of my formula and just work with that pi r s. So what I have then is I've got 2 pi r squared for the hemisphere, the outside part of it, and then pi r s. So as I substitute in my values, pi, we're going to substitute in the radius, and that's r squared, plus, and then we've got pi, the radius is 5, and then the slant height is 13. Okay, 5 squared gives me 25. 25 times 2, that would give me 50. So I'm going to look at this as 50 pi. And then 5 times 13 is 65, so I got 65 pi. And so the best way to write this answer, because it's a nice exact number, would be 115 pi. Now if we're asked to round, again, just use that pi button in your calculator. So it works out to be approximately 361.2832, and I could go on, but I'll just stop there. So approximately that many centimeters squared. Okay, all right, so that's the surface area. That wasn't so bad. Okay, volume's a little bit easier because I don't need to do any formula manipulation or think about what is actually here. So for the volume, we've got the hemisphere volume plus the cone volume. So hemisphere we said was 2 pi r cubed over 3, and for the cone that would be pi r squared, so the area of that base, times the height of the cone, and that would really be a cylinder, and a cone is a third of that size, so we would divide by 3 there. Okay, so substituting in, so we get 2 pi, and then it's 5 cubed, divided by 3 plus, and we've got pi, and it's r squared, so that's 5 squared, and then the height here is 12. Okay, remember you're distinguishing between the slant height and the regular height. It does make a difference. Okay, so we'll bring this back up. 5 cubed is 125 times the 2 is going to give me 250 pi divided by 3. And then we have for the cone, 5 squared is 25, and 25 times Well, in this case, because the 3 and the 12 can reduce, I'm going to make that a 1 and a 4. So 25 times 4 gives me 100 pi. Oops, sorry. Okay. And so if I was to write that as a total, I could write 100 pi. Another way of rewriting that is 300 pi over 3. And the reason I would do that is now I can write 550 pi over 3 altogether. Everything is nice and exact. If you do need to round that, again, type in pi as a button in your calculator, and that gives us approximately 575.958 centimeters cubed. Okay, so that is volume and surface area of spheres and hemispheres. And yeah, now we can do fun things like ice cream cones. And who doesn't love ice cream?